Alright, now we're going to build off yesterday's lesson on triangles, and we're going to talk about how we classify and organize information around quadrilaterals, or four-sided figures. As you will see behind me, some of the board has already been filled in today. That's because I started this video and then I had a little bit of a battery issue with my camera, so instead of starting from scratch with rewriting all that stuff, we're going to leave it up there. Okay? And unlike other videos where I'm using multiple boards, to help us make sense of quadrilaterals and how they're organized, we're going to use one board, we're going to go together through this, and really try to make sense of the hierarchy of four-sided figures. At the very top is quadrilaterals. Quadrilaterals are any four-sided polygon. And as you know, in order to be a polygon, you have to have straight sides and you have to be a closed figure. Some examples of quadrilaterals, again, four sides, that's the only requirement, is a shape like this that's similar to a chevron. It's got 1, 2, 3, 4 sides. This trapezoid here, 1, 2, 3, 4 sides. You may be asking, what are those blue marks? We're going to find out here in about 30 seconds. A square, four-sided figure. A rhombus, four-sided figure. Rectangles, and if you'll excuse me, my rectangle isn't perfectly straight. I am trying to draw on a board after all. And then parallelograms. This parallelogram is not closed. It's not a polygon until right now. Now it's a parallelogram. Okay? And if you'll remember from previous videos, quadrilateral, when we use the term parallel, that means two sides that will never touch. Okay? Two lines that will always be equal distance apart at every point on those two lines. Quadrilaterals is the top of the hierarchy. Everything that falls below it counts as a quadrilateral and will have all the properties of a quadrilateral. But then we can sort them into two separate groups: parallelograms and trapezoids. Parallelograms have two sets of parallel lines, which means, like I said, one set of parallel lines and then two sets of parallel lines that will always be equal distance apart. The other sorting is a trapezoid, which only has one set of parallel lines. Now, it is entirely possible to be a quadrilateral and not be a parallelogram or a trapezoid. And if we look at our figures up here, one of those figures is just a quadrilateral. That's as far as it will go in the sorting. We'll let you see if you can pick it out. If you picked out the chevron, you're correct. Because this chevron shape, while it's a quadrilateral, its lines intersect. This line and that line intersect. This line and that line intersect. This line and that line. None of the lines are parallel. So it can't be a parallelogram, and it cannot be a trapezoid. This is a trapezoid. This bottom line and this top line, the sides of the trapezoid, are a set of parallel lines. They will always be the same distance apart, and if we kept drawing these lines out this way, like railroad tracks, they would never touch. But these two lines, the vertical lines, if we extended them past the board, they would intersect somewhere up here. As you can see, I've moved the trapezoid over here to the trapezoid column. Another type of trapezoid that you may see looks like this. You may see them in your 10-gram sets, where it has a long line on the bottom that's parallel to a shorter line on top, and these two sides, again, will intersect. It almost looks like if you could visualize a triangle cut in half. Okay. Next we have a square. A square is a classic parallelogram. This set of sides and then this set of sides will never interact. They'll never touch. Sure, this line and this line, adjacent lines, will intersect. But that's not what makes a parallelogram a parallelogram. One set of parallel lines, two sets of parallel lines. And I use the little tick marks like we used in the triangle video to indicate that these two sides are the same length. Then my camera froze up while I was going through rhombuses. Rhombuses look like squares, but they have a little difference that we're going to talk about later. A rhombus has these two sides that are parallel, along with this side is parallel to this side. That makes it a parallelogram. I'm going to try to draw a rhombus, but that's not perfect. Next is a rectangle. Rectangles are parallelograms also, because this line is parallel to this line. They'll never touch. This line is parallel to this line. It'll never touch. Last is this shape. That is a parallelogram also. It's almost like someone took the rectangle and slanted it slightly. This line is parallel to this line. There's one set. This side is parallel to this side. There's two sets. See, I didn't draw that parallel. Bam. Now, after parallelograms, we can keep sorting. But trapezoids, we're pretty much done in this column. Okay? So I'm going to swap sides, and I may be out of camera length, but we'll try to make it so you can see me a little bit. Parallelograms can then be sorted into two categories. Rectangles and rhombuses. Okay? Rectangles have 90-degree corners. We've talked about that in the past with triangle videos and the angle video. Alright? They can be represented with that little square in each 90-degree angle. You will notice that parallelograms don't have any 90-degree angles, and rhombuses may have 90-degree angles, but they also might not. Some examples of, let's now sort these out. Squares, check that out. They have 90-degree angles. Oh, make sure it's a polygon. Rectangles have 90-degree angles. Parallelograms do not. Rhombuses may, but they may not. Now, a rhombus has four congruent sides. Remember that term congruent means same. Four sides that are the same length. That leaves us this shape and then this shape. Okay. A square is a type of rhombus. And then now, my sides aren't exactly the same length there, but for what I'm trying to get to, sometimes you have to trust the math, not this drawing or modeling. All four sides are the same length. Now you'll notice, I didn't use a parallelogram. A parallelogram isn't a rectangle. It isn't a rhombus. The only qualities it has of a quadrilateral is that it's a quadrilateral and it has two sets of parallel sides. Just like our chevron stopped with being a quadrilateral, a parallelogram stops at the parallelogram level. Now also remember that rectangles and rhombus as a subcategory of parallelograms, that's a subcategory of quadrilaterals, means all these properties above it apply. Okay? Trapezoids, they're not rectangles, they're not rhombuses because they're not parallelograms. Now you'll notice, I'm sure, that there is one shape that both rectangles and rhombuses have in common, not column. And that is squares. Squares are the only regular quadrilateral. Same shape sides, same shape angles. A square is both a rectangle and a rhombus. It has the angle measures of a rectangle and the side measures of a rhombus. So all the properties of quadrilaterals apply to a square, except properties of a trapezoid, because it's a parallelogram. Okay? So looking at our quadrilateral terms, we've talked about parallelograms, 2 sets of parallel sides. We've talked about trapezoids, 1 set of parallel sides. We've talked about rectangles, parallelograms that have 4 90-degree angles. We've talked about rhombus, which are parallelograms with 4 congruent sides. And then squares, which is the only regular quadrilateral. See you next time.